let's suppose that for some reason I'm asked to find the prime factorization of some number. So the key words here are, I want to find prime factorization. Remember, primes are numbers like 2, 3, 5, 7, 11, 13, and so on. These guys are the guys who's larger than 1, and the only factors are 1 and the number. So when I'm asked to find a prime factorization, I'm being asked to write the number as a bunch of products of primes. So factors, remember, being a word that means something you multiply together. So factorization, this is something that all multiplies together to be 294. So the way I'm going to do this is I'm going to make myself a little upside down tree that shows things that multiply together to the thing above them. So how this is going to work, I'm going to take 294, and basically I'm going to start at the beginning of my list of primes. Does 2 go into 294? It does. Okay, and if I divide 294 by 2, I'm going to get 147. Okay, 294 divided by 2 is 147. Sorry, 147. So I put the 2, I put the 147. Now 2 is on that list of primes, so it's done. So I'm going to circle it. 147, I don't know if it's on that list or not, but if I look at it, I can see that it's not divisible by 2. So I'm kind of done with 2. I wonder if it's divisible by 3. So if I take out my calculator and type that in, or remember my trick of adding together the digits, 1 plus 4 is 5, plus 7 is 12, so that's definitely divisible by 3. And in fact, it's 3 times 49. Okay, so I couldn't divide it by 2. I tried dividing it by 3. That worked. It's 3 times 49. 3 is on that list of primes, so I can circle it. 49, I don't think is, but let's see. Can I divide 49 by 2? No, it's not even. Can I divide it by 3? No, that doesn't work exactly. Can I divide it by 5? No, it'd have to end in a 0 or a 5. What about 7? If I divide 49 by 7, I actually get 7 left over. So 7 times 7 is 49, and 7's on my list of primes, so I'm going to circle both of those, and I'm done. Okay, I've circled the end, or circled the last number in each branch that I wrote. So I can say that 294 is 2 times 3 times 7 times 7, or sometimes, since this is itching to get us closer to number theory, I'll write this as 2 times 3 times 7 squared. So the prime factorization of a number, take that number and write it as a product of primes. One way you can do that is by making this tree. 294 is 2 times 47, 147. 147 is 3 times 49. 49 is 7 times 7. Grab all of those primes and put them together for your prime factorization, sometimes using an exponent instead of just writing out the factors.